Hi friends, welcome back to my channel. Today we are going to see Tsspdcl previous year question paper. First question, which of the following materials has the lowest temperature of coefficient? Options are carbon, constantan, manganese, tungsten. Answer is manganese. And if manganese option is not there, then the answer is going to be constantan. If they are asking zero temperature of coefficient, then one more option is there, that answer is eureka. If zero temperature of coefficient is asking, then answer is going to be eureka. Second question, the unit of conductivity is mho per meter, mho meter, Siemens meter. The answer is going to be mho per meter, and also called Siemens per meter. Third question, two resistors of 3 ohm and 5 ohm in parallel are connected to a DC supply of 15 volt. If 3 ohm resistor is short circuited, then theoretically the supply current is. What is given is, we have 3 ohm resistor and 5 ohm resistor connected in parallel with a 15 volt source. Then if 3 ohm resistor is short circuited, this is 3 ohm, this is 5 ohm. If 3 is short circuited, then theoretically the supply current will be, whenever there is in parallel paths, if any short circuit is there, means in short circuit current is infinity, because resistance we have is 0 in short circuit path. So current is always try to flow in a low resistance path. So here we are having a 0 resistance, so current is flowing infinity, because we can also see from Ohm's law, I equal to V by R. When resistance decreases, current is going to be increased. So here resistance is 0, 1 by 0 will be infinity. So current is going to be infinity. Infinity is the answer. Next, fourth question. The equivalent quantity of conductivity in a magnetic circuit is. Conductivity in a magnetic circuit, it is going to be permeability. If he is asking inverse of conductivity, then the answer is going to be resistivity. In if he is asking equivalent quantity of conductivity inverse of magnetic circuit, then answer is going to be relectivity. If not mention magnetic circuit, then answer going to be resistivity. Here he is asking the equivalent quantity of a conductivity in a magnetic circuit is, then the answer is permeability. If he is asking equivalent quantity of a conductivity in circuit, only he is asking circuit, inverse of conductivity in a circuit, then answer going to be resistivity. If he is asking the equivalent quantity of conductivity in a magnetic circuit is inverse of, then answer is going to be relectivity. Next question. A DC voltage source of 30 volts has an internal resistance of 2 ohm. It is equivalent to a. The voltage source we have voltage source and some internal resistance in series with the voltage source and connected to some load here. So here we given 50 volt of voltage source and internal resistance of 2 ohms. If we convert into current source, then I equal to V by R. V is 50, resistance given is 2 ohms, so answer is going to be 25 amps of current source. He is given 30 by 2, 15 of amps current source in parallel with 2 ohm resistor. Because in current source we have internal resistance connected in parallel. So answer is going to be B. Next question. A conductor is at constant speed rotating in uniform magnetic field. The EMF induced is maximum when the angle between movement of conductor and magnetic lines of force is. We have formula, induced EMF formula, E equal to BLV sin theta. B is the flux density. Flux density Weber per meter square are the units. L is the active length of the conductor and V is the velocity of the conductor. Sin theta is the angle between B and V, means flux density and velocity of the conductor. When will be it will be maximum? If EMF if we want to maximum, then sin theta should be 1. Sin theta, when it going to be 1? When sin theta equal to 90 degrees. When theta is 90 degrees, then EMF will be maximum. So answer is 90 degrees. Next question. 7th one. In a DC circuit, 4 branches are connected to a node. If the currents entering through 3 branches are 3 amps, 1 amps, minus 2 amps, then the absolute value of the current leaving in the 4th branch is. He is asking, if you know node, it is having node. If currents entering are 3, currents entering through 3 branches, 3 amps, 1 amp and minus 2 amps means it is leaving. Then absolute value of current leaving in the 4th branch. In node, the sum of currents coming equal to the sum of currents leaving. The sum of currents entering is equal to the sum of currents entering. Here we see 1 amp is entering and 3 amps is entering and minus 2 amps is leaving. Minus 2, and what should be the value in 4th branch so that this going to be equal. Here 3 and 4 and 3 plus 1 4 and here minus 2. If we place 2 amps here, if 3 currents are entering through 3 branches, 3 amps, 1 amps, 2 amps, means here also 2 amps it is entering, because 3 are entering given. Entering is minus 2. So leaving only. minus 2 means leaving. So what should be the value here? So that we got 4 value. If we place minus 2 plus 6, then it is going to be 4. So answer is fourth branch is 6. Next question. In a DC series motor, if the load current increases, then voltage drop across the field resistance. Options are increases, then decreases, and increases. If you see series generator, this is the armature and this is the VT. This is the output we take. Here we generate EG, means generated EMF. Okay, this is the series field winding. Okay, so whatever the voltage generated, it should be go through a series field winding. So series field winding is having some resistance, so some drop will be there. If load is increases, then armature current is going to be increases. So drop in series resistance is also increases. So first it is going to be increases because due to voltage drop, then there is a reduction in voltage. So then after voltage drop will be decreases. First voltage drop is increases, then decreases. Answer is option B, increases and decreases. Next to 10th question. If field winding of a DC series motor is open circuited, then now only we see series field winding. In series field winding, the field winding is connected in series with the armature. So motor should have field winding as well as a armature winding. If we open this series winding, then there is a no field flux. The motor should have field flux as well as armature flux. If field flux is 0, then motor is going to be 0 because it is connected in series. If we open circuited, means total machine is open circuited. So speed will be 0. Motor will stop. Otherwise, another option is there, motor will stop. Both are correct. Here option given is speed will be 0. Option B, speed will be 0. Next question. During field weakening of separately excited DC motor at constant supply voltage, options are speed decreases, speed remains constant, speed increases, torque is constant. Here is given field weakening means flux control method. This is one of the method of speed control of motors. Flux control method. In this, what we do is to increase the speed of a machine above rated speed. Speed is inversely proportional to V by pi. Field weakening method means flux is decreasing by introducing some resistance or some other method. We are decreasing the field current. Field current decreasing means field flux also decreases. Field flux decreases means here decreasing, field flux is decreasing means speed is going to be increases. So answer is speed increases, option C. Next question. In a voltmeter, voltage of a 10 under root V deflects by an angle of 90 degrees, where deflection torque is proportional to angle of deflection. If the deflection is 45 degrees and the controlling torque is gravity control, then the reading is in gravity control. Controlling torque is gravity control. In gravity control, we have controlling torque proportional to sin theta. Sin theta. Here reading is voltage when angle is 90 degrees. What will be the voltage if angle is 45 degrees? So controlling torque Tc2 by Tc1 equal to sin theta 2 by sin theta 1. This 10 root 3 is V1, 90 degrees is V2, T2, and this angle 45 degrees is theta 2. This 90 degrees is 1. If you substitute all these values, then the answer you will get be 10 volts answer. Next question. The meter constant of a single phase energy meter is 600 revolutions per kilometer. If it makes same number of revolutions in 1800 seconds, then the load is here 1600 revolutions per kilometer, means he is given meter constant K equal to number of revolutions by kilowatt hour. So he is given 600 by kilowatt hour. Means what is means in 1 hour it is going to be, in 1 hour if it makes 600 revolutions, then meter reads 1 kilowatt hour reading. Means 1 unit equal to 1 kilowatt hour equal to 1 unit of reading. He is given meter constant, means he is disk is making 600 revolutions per kilowatt hour if it makes same number of revolutions in 1800 seconds. Here we have denominator kilowatt hour. Kilowatt hour means hour. If we convert into seconds, 60 into 60, then it is going to be 3600. So for every 3600, if meter makes 600 revolutions, then reading will be 1 kilowatt hour. He is given 1800 seconds only, this disk 600 revolutions completed. Means in 1800 seconds only disk makes 600 revolutions, means 1 kilowatt hour reading completed. Again 1800 seconds, total 3600 seconds. Again 1800 seconds, disk will make 1 kilowatt hour reading. So total 1 kilowatt hour going to be 2 kilowatt hour reading. Here options are given: 500 watt, 1000 watt, 2000 watt, 5 kilowatt. Answer we got is 2 kilowatt. 2 kilowatt. Kilo means 10 to the power of 3. 10 to the power of 3 means 3 zeros. So 2 into 3 zeros. 1, 2, 3. So 2000 watt is the answer. Next, 14th question. The range of dash can be increased by connecting a low resistance in dash within. Low resistance means in ammeter we have low resistance in ammeter. How ammeter is connected? Here ammeter, we have ammeter and the low resistance is connected in parallel with ammeter for extending the range of ammeter or not. So answer is going to be option B. Next question. In a CRO, to display an unknown waveform on the screen, The waveform to be fed to Y plates is, options are unknown waveform, sawtooth, sinusoidal and DC, and answer is unknown waveform. Thank you for watching. In next part we are going to cover next questions. Thank you for watching.